Okay, we're going to start with a real quick review of multiplication from yesterday. So back in grade 9, we had our monomial times a binomial. It went 3 times x, which is 3x, and then 3 times plus 5, which is 15. Then we moved into slightly different, a little bit harder. Now we have to multiply them by a negative 4. So just outside the brackets, we have to include that negative sign with the 4. 3 doesn't change, and we get negative 4x minus 8 when we multiply in. Collect like terms, 3 minus 8 is negative 5, and minus 4x doesn't change. Now, if you want to write negative 4x first, you're welcome to. These are exactly the same, okay? So same answer because the signs are the same and the terms are exactly the same. All right, then we multiply in by a monomial, so 3 times 4x, so we got 3 times 4, which equals 12. Then x times x, we add our exponents, so we get 1 plus 1, x squared. So we multiply the same base, you add your exponents. And so if you multiply different bases, you keep both letters, you write them side by side, and they stay as a multiplication, x, y, which is x times y. Next question, you have to multiply in or add the opposite, but this is like a negative 1 that you multiply in with to drop your brackets correctly, minus 2x minus 3y. And so your signs change, and you'll often hear teachers say the phrase add the opposite. That's essentially what you're doing, same idea. Collect like terms, 5x minus 2x is 3x minus 3y. Okay, next one we have the same question here. So this is grade 10, binomial times a binomial. Two different ways of looking at it, just two different ways of showing the exact same thing. So the method 2 is what I like best. So we have x times everything. So we have x times x minus 3. And then using the distribution law, that's what we're focusing on yesterday and today, distribution law, to make sure everything multiplies correctly. We then take our plus 2 and we multiply it by all the terms, x minus 3. And so when we combine them, what we get is x squared minus 3x plus 2x minus 6. So we multiply in now. And then, of course, we always have to combine our like terms, which are going to be in the middle. And that's our final answer. Now, if I want to do it the different method, I'm going to do the exact same thing, but I'm going to use distribution law. So I'm going to take x and multiply it in. X, multiply it in. And yesterday you had me saying, or heard me saying FOIL rather. So I'd say FOIL as I'm doing this because that helps us remember the proper order. Multiply in and multiply in. Again, if you want to write your arrows on the top, you would be welcome to do so. Collect like terms, as always, x squared minus x minus 6. Exact same answer, two different methods of showing your work. This method here, though, method 2, it's very powerful. It's going to help you for questions later on that are a little more complicated, okay? But both methods, you are working vertical. You want to work down the page because then you can see where things arrive from, how things change. Okay, so it's really important that you work down so that you can see those changes and catch mistakes in your work. So let's do some examples here. I'm going to do method 1 on the left and method 2 on the right. So method 1, multiply, x squared minus 5x, and then we're going to get the plus 2. Always include those signs, even if they're positives. You want to say it so you don't screw it up with the negatives. So that's negative 2, positive 2 times negative 5. Collect like terms, minus 3x minus 10. Method 2, I'd write it out, x times x minus 12. And then plus 4 times x minus 12. And so I get x squared minus 12x plus 4x minus 48. X squared minus 8x minus 48. Okay, good. Now what's important to see here is that here are the larger digit 5 is negative, and then we get a negative result when we collect like terms, or a negative sum, wherever we want to talk about it. Here the larger digit is 12 and it's a negative, and look in the middle, it's negative 8. So the sum in the middle, where we combine terms in the middle, they'll always have the sign of the larger digit. Okay. Next, same idea now for the next question, but now we have different letters. So we're going to have x times x, which gives us x squared. X times minus 4y, which gives us negative 4xy. Then we have negative 2y times x, so negative 2xy. We do try and keep these alphabetical, and then it's easier to compare them. And then negative 2 times negative 4. Notice how I'm including the negative signs when I'm saying things, because that multiplies to a positive 8. Okay. Collect like terms in the middle, x squared minus 6xy plus 8y squared. Okay, number 8, try it yourself. Again, I'll go 8a times 3a minus b minus 3b times 3a minus b. Multiply in 24a squared minus 8ab minus 9ab plus 3b squared. So I'm multiplying a negative 3, this last one, a negative 3b times a negative b. Okay. Collect like terms in the middle, pretty cool. They're both AB terms. Again, write them alphabetically, makes it easier to notice that they're the same terms. And you get negative 17ab plus 3b squared. Okay. Next two. So this one, the multiplications are going to get a little bit more. So when we're multiplying this one, we're going to multiply the two terms that are side by side first. Okay, you can only do a single multiplication at a time. And then write your answer in brackets. And now you're going to multiply that by x minus 5. So a couple things, you must have brackets. Okay, you must have brackets in that term. And so then we have a question just like up above. And so then we do another multiplication. So we would get 2x times x, which is 2x squared, 2x times plus minus 5, negative 10x, 6 times x, 6 times plus 5. Okay, there we go. Collect like terms, and we get 2x squared minus 4x minus 30. So the idea here is one multiplication at a time. All right, so one multiplication at a time. That's the important thing to remind you there. All right, I've seen some weird stuff with this. Now number 10. Now the other way to write this question, if you wanted to, you could write it as x plus 3 times bracket, x plus 3 bracket x minus 5, and then put a 2 on the end. Or x minus 5 times x plus 3 times 2. So you can change it in any order. This is the difference between 2 times 6 times 5, right? Versus 6 times 2 times 5 versus 5 times 2 times 6. Okay, so they're going to give you the exact same answer. So if you want to, you can always rearrange questions when you're doing your work. Now number 10 is really good if you remember that it's x times all three pieces. And then it is plus 2 times all 3 pieces. Okay, so that's essentially what we have when I write it out this way using distribution law. I have my x at the front and its multiplications, and my plus 2 at the back and its multiplications. So when I multiply, I will get 2x cubed. Watching my exponents, I add them together. So x times x squared, that equals x1 plus 2 on my exponents, which equals x cubed, minus 5x squared plus 1x, plus 4x squared minus 10x plus 2. Collect like terms, there's only one x cubed term. My x squareds are negative 5 and plus 4, gives me a negative 1x squared. And I have 1x and negative 10 minus 9x plus 2, final answer. So now the multiplications are a little more challenging. So number 11, what does it mean? Well, it actually means 3a minus 2b times itself, 3a minus 2b times itself one more time, 3a minus 2b. And that's because the exponent is a 3. So again, we only multiply by what's side by side. So we multiply those two first. This one at the back does not change. It stays there exactly the same. So I multiply the front two, and I will get 9a squared minus 6ab minus 6ab plus 4b. Middle terms collect. 9a squared minus 12ab plus 4b. Now, I don't really like this here, so I'm going to move it up to the front because I'm more comfortable with it there. 3a minus 2b. I mean, you could work it from at the back, no big deal. That's just personal choice. Okay, so now I take 3a and I multiply it in. So multiply, multiply, multiply. And I get 27a cubed minus 36ab plus 12ab. And that should be a squared b here, 36a squared b. Good, then I'm going to do the minus 2b, multiply it in, and get minus 19a squared b plus 24ab minus 8b squared. So I can collect like terms, but I got to really watch the exponents. I can collect these guys here, negative 36 and negative 19. Those are going to get quite large. I will then go 27a cubed minus 40. Ooh, sorry, it's late. 36 plus 19. Okay, so negative 55a squared b, and then 12 plus 36 ab minus 8b squared. There we go, final answer. Okay, so these ones are real pains. Some of you on your test, you're going to get one of each type. That's it. You're not going to get 4,000 of these. One each type. Make sure you know what you're doing. So question 12, I will multiply this one in. Boom, boom, boom. I get 2x4 plus 6x cubed minus 14x squared. Then multiply the middle one in. Boom, boom, boom. We get negative 5x cubed minus 15x squared minus 35x. And then I'm going to multiply the green one in, the last term in. Boom, boom, boom. And I will get I wish I could extend it, but I can't. So plus 4x squared plus 12x minus 28. Collect like terms. There's only one x4, x cubes. So 6 minus 5 is 1. So plus 1x cubed. I don't have to write the 1. Then we get negative 14x squared, and this will be negative 29. And plus that would be negative 25x squared. And then we have the x's, 35 negative plus 12 would be 23. So negative 23x minus 28. And there you have your answer for that one. Okay. Let's see here. Okay, so this one is absolutely a challenge question. So what we're going to do is we're going to find the area of the shaded region. So just the area of this section right here. So what we are going to do is find the area of the entire shape and subtract this area so it's gone. And that will give us the area of the shape that we want. Okay, so it's going to be the total area and subtract the unshaded area. So let's do that first. And first of all, we need to get this entire length, so we'll add those up. The entire length then would be 5x plus 3. And we're going to add up this entire length. That would be 3x plus 12. And so the area would be length times width, right? Area equals length times width. So I would multiply 5x plus 3 times 3x plus 12. And then we're going to subtract the area of the unshaded region, which is 2x plus 5 times 2x plus 5. That is a perfect square. Okay. And what we have to be careful of, the trick with this question is right here. Your answer must be in big square brackets because of the subtraction sign. Otherwise, you're not going to subtract correctly. So let's multiply these out. We're going to get 15x squared plus 60x plus 9x plus 36. So we get 15x squared plus 69x plus 36. Then we multiply the rest out. So minus bracket 4x squared. Okay. 4x squared plus 10x plus 10x plus 25. Collect like terms. 20x plus 25. Oops, big square bracket there. And then I'm going to rewrite it and drop my brackets and make sure my signs get fixed. So the first polynomial, nothing happens. But here now, these signs all change. So that becomes a minus 4x squared, a minus 20x, a minus 25. Then I will collect like terms, the last little bit here. So it would be 11x squared, 69 and negative 20 would be 49x. And then 36 minus 25, 36 minus 25 equals 11, so plus 11. Okay, so that's doing method number 1. Method number 2 is you just break this up and you find your area. So this here would be 2x plus 5, and this area right here, the whole thing, is going to be 3x plus 2. Okay, sorry, 3x plus 12. And so we're going to get, for the area of the large square, 3x minus 2 times 3x plus 12. And we're going to add it to the area, 2x plus 5 times x plus 7. So we add them up. We get 9x. Ooh, I need a lot of space here. 9x plus 36x, that'd be x squared, plus 36x minus 6x minus 24, plus 2x squared, plus 14x plus 5x plus 12. Collect like terms, and I get 11x squared plus 50. Oops. Now I could collect like terms here and here, then combine them. I'm just going to do it all at once. So 36 minus 6 is 30, plus 14 is 44, plus 5 is 49. So plus 49x. And then you have 24 plus 12. Ooh. Is that correct? Ooh, 5 times 7 is not 12. 5 times 7 is 35. Good catch. 35. And that makes more sense because then we get a positive 11. And then you can see our two answers match. Whew, there we go. So the look, it starts easy, but then it gets